Hello everyone. Welcome to Explore Operational Property Graphs in Oracle AI Database workshop. This workshop focuses on working with property graphs in Oracle AI Database and illustrates how you can model your data as graph and run graph queries in SQL to quickly see relationships in your data that are difficult to identify otherwise. In this lab, you will learn how to create operational property graphs inside of Graph Studio. Query the newly created graph, bank graph, using SQL PGQ and an extension in SQL 2023. Run queries using SQL PGQ's graph table operator, match clause, and columns clause. Run Python PGX interpreter and use the Python API to run the PageRank algorithm. And use graph machine learning algorithm like DeepWalk to find accounts that have a similar structure. Let's get started. Once you have created your sandbox environment and logged into Graph Studio, which is one of the applications that's available in Oracle Autonomous AI Database, you will be brought to this Graph Studio homepage. In this lab, you will be creating an operational property graph inside the Graph Studio. Let's click on graph icon. Click on create graph. Graph name, we will give it as bank graph. Description is optional and we will click next. Let's expand graph user and we will be selecting here bank accounts as well as bank transfers table and move them to the right. That is here. Let's click on the first icon in the shuttle corner. Click next. The suggested graph has bank accounts as vertex table since there are foreign key constraints specified on bank transfers that reference it. And bank transfers is suggested here as edge table. Click next. In the summary step here, click on create graph. This will open create graph tab. Click on create graph. The bank graph is a view on the underlying tables and metadata. This means that no data is duplicated. Now we will proceed to the next lab. For that, we will click here on the notebook icon here. In this lab, you will query the newly created graph, that is bank graph, using SQL PGQ, a new extension in SQL 2023. First, let's open the notebook, bank graph. Here, we will be using SQL PGQ's graph table operator, match clause, and columns clause. To give some background, graph table operator enables you to query the property graph by specifying a graph pattern that you want to look for and return the results as a set of columns. The match clause lets you specify the graph patterns and column clause lists the query outputs column. Everything else is in SQL syntax. A common query in analyzing money flows is to see if there is a sequence of transfers that connect one source account to a destination account. We will be demonstrating that sequence of transfers in standard SQL. Note that we created the graph using Graph Studio Modeler in the previous task. Here we have provided the create statement here for create property graph SQL statement, which you can use to create graph anywhere SQL queries are supported. We have already created this, so we will not be running this query. Now, first one, let's use this SQL statement here to find top 10 accounts by number of transfers the account has received. So let's run this query. Here we see that accounts 387 and 934 have a high number of incoming transactions. Now, what if we want to find accounts where money was simply passing through? Let's find top 10 accounts in the middle of two hop chains of transfer. For that, we will run this query. Note that 387, it appears here again. So let's list accounts that received a transfer from account 387 in 1, 2 or 3 hops. So here we have this query here where we are looking for 1, 2 and 3 hops for account 387. Let's run this. Here we see the list of accounts that received transfer from account 387 in 1, 2 or 3 hops. We looked at accounts with the most incoming transfers and those which were simply convicts. Now let's query the graph to determine if there are any circular payment chains. That is a sequence of transfers that starts and ends at the same account. First, let's check if there are any 3-hop triangles transfers that start and end at the same account. Here is the query for that. Here we are looking for 3 hops. Let's run this query. Now we can use the same query but modify the number of hops to check if there are any 4-hop transfers that start and end at the same account. We are running the same query. We have just changed this number to 4 now. Here we see the list of such accounts where the number that starts and ends with the same account and number of hops are 4. Lastly, let's check if there are any 5-hop transfers that start and end at the same account just by changing the number of hops to 5 here. Note that although we are looking for longer chains, we reuse the same match pattern with a modified parameter for desired number of hops. The compactness and expressiveness is a primary benefit of SQL syntax for graphs in Oracle AI database. Let's learn this query. Now we have seen that there are 3, 4 and 5 hop cycles. Let's list some any 10 accounts that had this circular payment chain. Let's run this query for that. Here are the account IDs that have 3, 4 and 5 hop cycles. Now let's list the top 10 accounts that have circular payment chains of 3 to 5 hops in descending order of number of such chain. Here we are putting a clause here, order by, and hop number is 3 to 5. Note that account 135, 387 and 934 are the ones involved in most of the 3 to 5 hop circular payment chain. Any insert, update or delete on the underlying table will also be reflected in the property graph. Now let's insert some more data into bank transfers. We will see that when rows are inserted into the bank transfers table, the bank graph is updated with corresponding ages. Here we are inserting these 6 rows. These are the source account IDs and these are the destination accounts. Let's run this. Query executed successfully. Affected rows number 6. Now we will rerun this top query to see if there are any changes after inserting rows in bank transfers. Notice that account 135 and 934 are now ahead of 387. So here 387 is at number 3 with 339 number of transfers, and if we see the previous query, here 387 is at number 2 with 34 cycles. Now let's check if account 39 had any of these 4-hop circular payment chains. We have a query for that here. Account ID is 39 and number of hops is 4. Let's run this. It has 0 4-hop circular payment chains. Let's insert more transfers which create a circular payment chains for this account 39. We will be adding transfers from account 559, 982 and 407 into account 39. So these are the source accounts and the 39 is the destination account. Query executed successfully. Now let's rerun the previous query again. Notice that we have now five 4-hop circular payment chains because the edges of bank graph were updated when additional transfers were added to bank transfers. We inserted 3 rows and that has resulted in 5 circular payment chains of length 4. Let's examine why. By executing the query below here, what we are seeing here, we will find the number of 3-hop chains from account 39 to one of the accounts 407, 559 or 982. Here there are 2 chains from account 39 to 407 and another 2 from 39 to 559. So when we inserted a transfer from account 407 to account 39 that resulted in 2 4-hop chains, the same occurs for account 559. Hence, we get 5 new 4-hop circular payment chains here. Let's undo the changes and delete the newly inserted rows. Query executed successfully. Now here we are going to run our first Python PGX paragraph, which uses the built-in session object to read the graph into memory from the database and creates a PGX graph object that handles the loaded graph. Page graph, bank graph successfully loaded. We are going to start looking at some of the accounts we know that 387 and 934 have a high number of transactions. So we are going to look into those accounts in details. Let's start identifying the owner of account 387. Here is the query for that. Looks like Antonia is the owner of this account 387. Now, what about account 934? So for that, we will run this query. The owner of account 934 is Russell Rivera. Now let's look at the circular transfers that originate and terminate at Russell Rivera's account and visualize the results. We start with the number of hops equals 4 as it is specified here, and the source name is Russell Rivera. Here we see that there are 3 circular payment chains, 4 hops in length that start and end in this account. This is Russell Rivera's account. Now we want to look at circular payment chains when we change the chain length of this chain to 5 hops. Here the number is changed to 5 and source name is again Russell Rivera. Let's run this. Here we see that number of circular payment chains that start and end with this account for Russell Rivera. It definitely makes this account that we should investigate further. So let's continue our investigation using another algorithm, the page rank graph analytics algorithm. Python PGX paragraph lets you execute Python code snippets. We will use Python API to run PageRank algorithm. The code snippet below here This creates a page graph object containing a handle to bank graph loaded into the memory. Then it executes the PageRank algorithm using the built-in analyst Python object. The session and analyst objects are created when the in-memory graph server is instantiated and when a notebook is open. Let's run this. Now let's list the PageRank values in descending order to find the accounts with high PageRank values. A high PageRank value indicates that the account is important, which is in the context of bank graph, a high number of transfers that have flown through this account, or the account is connected to other accounts with a high number of transfers flowing through them. Let's run this. We see here Russell Rivera is in the top 5 here. So the metric also indicates that a large number of transactions flow through Russell Rivera's account, but he is not at the very top. Interestingly, Antonia is at the top of the list. Now let's use the computed PageRank value in visualizing the result. We use highlights to display the accounts with a high PageRank value with larger circles and red color. Execute this paragraph with the following query, and this finds 3-hop payment chain starting at Antonia's account. So here source name is Antonia and 3-hop chains we are trying to find. From visualization here, we can quickly see which accounts are connected to Antonia's account. This is Antonia's account, and the accounts that are connected to Antonia also have high PageRank value. So far, we know that, or we have the knowledge that highly connected account might be fraudulent, or when money flows or moves in cycle, then there is a potential fraud. What if we did not know about this specific domain? That cycles might indicate a fraud. What if only knew that we knew that only accounts 934 and 387 are fraudulent, but did not have any additional information on what patterns might constitute fraud? We can use graph machine learning algorithm like DeepWalk to find accounts that have similar structure to an account. We don't know what structure we are looking for or what exactly we are looking for in what is similar. That is the power of machine learning. You can find similarities even if you don't know what exactly you are looking for. Let's run this query. Query ran successfully. Now we will train the deep work model. We will be running this paragraph for that. Here, once it is run, we will see the time it took in order to train this model. So currently this query is training this model, deep work model, and we will see the result, and then we will execute more similar nodes to account 934. Here, deep work model training completed in 9.88 seconds. And now let's go and find more similar nodes to account 934 with respect to transfer patterns. Here, account 934. This is the list of most nodes that are most similar to node 934. Now we will take a look at similar nodes to account 387 with respect to transfer patterns. Yeah, this is the list of nodes most similar to node 387. We see that account 135, it shows up here as well as in the previous list 135. So this is closest to account 934 and 387 in terms of patterns of the connections that account is involved in. When we query for transactions like 2 hops away from 934, 387 and 135, we see that their patterns are similar. So let's add a highlight to see these accounts by giving a star icon, and you can also right click on them to check their account IDs. So let's run this query for that. Let's expand this. Yes, these are Antonia's account, Pergie's account, and Russell Rivera. You see here the pattern for Antonia's account and pattern for Russell Rivera's account and Virgie's account. There is a similarity. So this is how you can use the graph to see the similarity in between different accounts. With that, it concludes our operational property graphs in Oracle AI Database workshop. Thank you so much for joining me.